Once again, good day everyone. This time we will have two sample problems regarding the angle of friction. I hope that you learn about the angle of friction with these sample problems. So let's begin. And in our problem number one, I'll just read it. What force P must be applied to the wedges shown in the figure to start them under the block? The angle of friction for all contact surfaces is 10 degrees. In this problem number 1, we are required to find the force P that must be applied to the wedges to start them under the block. And in this problem, the contact surfaces has the angle of friction of 10 degrees. All the surfaces, meaning the block and the wedge and the ground has the same coefficient of friction. And to solve this, we first isolate the block above and determine all the forces acting on it. And in this block, there are three forces: the weight force of the block itself and the two resultant forces due to the friction made by the two wedges under it. And to know the location and the direction of the resultant forces, we will recall our discussion in the other video, in the first video. So first, we will draw a vertical line for the reference. Next, we will draw the normal force that the block will experience because of the wedge. And also, we will draw the friction that is made by the two objects. Notice that the angle of the wedge is the same as the angle of the normal force to the block. After this, same as our discussion in the previous video, we will make a parallelogram. Then we will construct the resultant force on it. Recall that the angle of friction should be in between the resultant force and the normal reaction. In this case, the angle of friction is 10 degrees. Notice that the wedges are symmetrical, so we can just copy the forces from one side to the other because it's just the same. The next thing we will do is to isolate the wedges, and the same as the block, we will put the forces acting on them. There are three forces acting on each of the wedges: the resultant force by the block, and the resultant force of the ground, and the force P, which we are finding. Next, we will use the equation of equilibrium, which is the forces vertical is equals to 0, to the free body diagram of the block. And the forces that are acting on the vertical direction on the free body diagram of the block are the weight force, which is 1,000 pounds, and the two resultant forces of the wedges, which are R1 times the cosine of 25 degrees. The 25 degrees came from the theta, which is 10 degrees, and the angle of the wedge, which is 15 degrees. 10 plus 15 is equals to 25 degrees. Solving this equation, we have R1 is equals to 551.69 pounds. Next is we will use the equation of the equilibrium to the wedges, only one of them. We will use the forces vertical again is equals to 0. We can see that the vertical forces acting on the wedges are the R1 cosine of 25 degrees and the R2 cosine of theta, which is 10 degrees. We already know the R1, so we can just solve the R2, which turned out to be 507.71 pounds. And lastly, we will use the forces horizontal is equals to 0 by the equilibrium equations to find the force P. Here, the horizontal forces acting on the wedge are the R1 sine of 25 degrees, the R2 sine of theta, and the force P. Substituting all the values that we know, we can now solve for the force P. So the force P that must be applied to the wedges to start them under the block is 321.32 pounds. Let us now proceed to number 2. In number 2, determine the force P required to start the wedge shown. The angle of friction for all surfaces in contact is 15 degrees. So this problem is just like the problem number 1, which we will find the force P that will start the wedge. So let us start. Same as the solution in problem number 1. We will first isolate the wedge, then put all the forces acting on it. We will then also make the free body diagram of the block. Next step is to find the R2. We will use the equation of equilibrium. The forces vertical is equals to 0 and the horizontal forces is equals to 0. In the forces vertical, we can see that the 200 kilonewton plus the R2 sine of theta is equals to R3 cosine of theta. Then for the computation, I will show you the calculation in the calculator. Here we can see the R3 is equals to 207.06 plus 0.268 R2. So next is the summation of the horizontal forces is equals to 0. From the FBD of the block, we can see that the horizontal forces is the R2 cosine of theta is equals to 50 kilonewton plus the R3 sine of theta. So next is we will substitute the above equation to the below equation. What a nice English. Then from here, we can see that we can now solve for the R2. We will just distribute the sine of 15 to the two terms inside. So we will use again our magic calculator. So now we have found the value of R2, which is 115.55 kilonewtons. Then with this value, we can now solve for the force P using the free body diagram of the wedge. So this time, unlike the problem number 1, we will use the easier way of solving the forces. We will use the force triangle method. So after we make the force triangle, we will now proceed in finding the force P. By using the force triangle, we will now use the sine law to find the force P. Again, we will use the calculator in solving the P. So, from the R2 that we have just solved, 115.55 times the sine of 45 divided by the sine of 60 will be the answer P. And the P will be 94.35 kilonewtons. And that is our final answer. And that ends my discussion and sample problems about the topic angle of friction. I hope that you have learned something about the topic. And I thank you guys for watching.